Hello students, today we will learn about surds and its rationalization. So first of all, let's say what are surds. Surds are irrational number with radical sign. They cannot be simplified. For example, if I say cube root of 2, this is a surd because we cannot simplify it. And the number outside the root, a small 3 here, is called the order of the surd. Cube root of 2 is a surd because it cannot be simplified. Likewise, if I say n root of a, this is a surd. An example of surd is a surd of order n. Hope you get it. What if I write square root of 3? What is the order of this one? It is a surd, of course, because we cannot solve it, but the order is, no number is written here, so you must assume that it's 2 square root. In square root, the 2 is not written, it's not shown. Cube root and higher are indicated by the number. If there is no number, it's a square root. So we'll be learning about this thing. If I write 25, root 25, is it a surd? Is not a surd, because root 25 is 5. You can solve it. So if it can't be solved, it's a surd. Otherwise, it's just a normal rational number. Now, what are we going to do here is we will be learning about rationalization of surds. Rationalization of surds. So just suppose you have a surd, and if you change it into a rational number, then it is called a rationalization. For example, I have 1 by, and just suppose this is a surd, 1 by root 7. So when do we rationalize surds? Whenever you have a irrational number in the denominator, this has to be rationalized. So 1 by root 7 multiplied by, to remove root 7 you have to multiply it by root 7, because root 7 into root 7 is 7. So if you just multiply and divide this one with the same number, root 7 into root 7 will become 7, and this will be 1 into root 7 is 7, root 7. So what have we done here? We have removed the root from the denominator and we got 7 here. So removing root from the denominator, or removing the surd from the denominator, is called rationalization of surds. So as a rule, if we have a surd in the denominator, we multiply both the numerator and denominator, we multiply and divide with root 7, and then here is your answer. One more example, if I have 1 by root 18, so what will I use here? 1 by 3 root 2. 3 root 2? Why 3 root 2? Because root 18 is not a surd. 18 is 2 3 times, 2 9 times, 3 times. So I hope you know how to take the square root. So here 18 is 3 root 2. So we have to convert it into a surd first, and then multiply it by root, the root part only, not the rational one. The irrational part has to be used. So you'll be multiplying by root 2 and root 2. So root 2, 3, root 2 into root 2 is 2. So you get root 2 by 6. This is how we solve. Hope you got this one. Now these are examples of how we solve surds. I could give you formula, but that might be a bit confusing, so I'll just avoid doing those part. What about a surd of this 4? How do you rationalize this one? It's same. You'll just copy this one first. 1 by root 1 plus 3 plus root 2, and then multiply it by 3. As this is plus, for this type of thing we use the opposite sign. We will multiply and divide using the opposite sign of this one. 3 plus root 2, here it will be 3 minus root 2, 3 minus root 2. Now these things are called the rationalizing factor. This is the rationalizing factor. The number which removes the surd is called the rationalizing factor. So here also this is root 2 is the rationalizing factor, and this is a rationalizing factor. So why do we use this one? In the previous class we had said that root 3 plus root 2, 3 minus root 3, multiply, you get 3 square minus root 2 square. That is using formula a square minus b square. So the same thing will be applied here. A square minus b square, and then if I multiply this to get a square minus b square, if I multiply this to 1 into anything is same, so you get 3 minus root 2, 3 square is 9, minus root 2 square is 2, so this is 3 minus root 2 by, so as I have told you before, that if I have removed the root from the bottom, the denominator, I have rationalized it. If the root is lying up here, there is no problem. The denominator should not have root. So the same thing applies here. The root from the denominator is gone. It's a plain number, a simple number, 7. 3 minus root 2. This root, we should not bother about this. Now this is rationalized. And if you rationalize this one, you will get this. Hope you have understood what I have said. So I will solve a few questions and then I'll give you your assignment. So let me solve one question for you from your textbook. It's question number 9. 3 root 5 plus root 3 divided by root 5 minus root 3. Okay, to solve this, as I have already said, we will be multiplying and dividing it with a number which is opposite to this, and the same thing will be repeated up here. So whatever is on this side, as I said, it does not matter much. This is your question. We have multiplied it and divided it with the same number which is opposite to this. So we had already learned this type of multiplication. Root 5 minus root 3, root 5 plus root 3 is a plus b, a minus b, and it can be written as a square minus b square. Now multiplying these two will be 3 root 5 plus root 3, and then root 5 plus root 3. So how did I multiply? I just use this to multiply it, and then root 3 was used again to multiply these two. Okay, so what will we get here? 3 root 5 into root 5 is 5. 5 into 3 is 15, plus root 5 and root 3 is root 15. There's a 3 root 15, right? Plus 3 into 5, 15. So root 15 if the number and root are same, root 3 into root 3 is 3. Root 3 into root 3 is root 9. Root 9, or that is simply 3. So you have to know this one. So here root 5 square will be 5, root 3 square will be 3, and then 15 plus 3 is 18 plus 3 plus 1, 4 root 15 by 2. So 18 and 4 have a common factor 2. So we take out the common factor so that it can be cancelled with this one. So the answer will be 9 plus 2 root 15. This is how we solve this type of question, and it should be kept in mind that any fraction which has a root in the denominator is to be simplified. It has to be rationalized to give a denominator without any root. Here the denominator is 1, as you can see, and it has no root. So I hope you understand this one. Might be a bit difficult, but you will need to practice a lot. Without practice, things cannot be easy. So your assignment will be exercise 1.4. I'll send you the picture later on, but you have to know the number here. Question number 3, 4, 5, 6, 7 and 10. 3, 4, 5, 6, 7 and 10. These are of the same type, rationalization of surds. So let that be all. Thank you.